What's the problem?
My hairdryer won't work!
What's wrong with what's wrong? Well,
It doesn't have enough power!
maybe I can power it.
I remember we learned about power in class!
Well, let's go try and figure this out.
Let's go!
We'll figure this out.
Three, two, one, go.
Okay, so I blow dry my hair for 1 hour every day. And we can say that my hair dryer needs 1200 watts per hour. I want to see if Connor can produce enough power to power my hair dryer for 1 hour, and if not, how long he can power it for.
Okay, so to test to see how much power I can produce, so then we can compare it to how much Emma's hairdryer needs, we went ahead and made a little experiment. And in this experiment, we're going to neglect air resistance and friction. So here's a little diagram we drew. And what we did is we measured the height of an individual stair in our stairwell. We found that to be 0.19 meter. We then found that there was 8 steps in total. So we did 8 steps multiplied by the 0.19 meters per step. And we found that to be 1.52 meters in total. So that's going to be our delta H for our equation later on. So at the bottom of the stair set, this is the initial gravitational potential energy. At the top of the stair set, we have our final gravitational potential energy. So to calculate the work, we're going to go ahead and use the work theorem of the negative change in gravitational potential energy. So we can calculate that by doing the mgh final subtracted by the mgh initial. Now, at the bottom, we have our height equal to 0. So if our height is 0 here, this is going to be equal to 0. So our work done is just going to be our gravitational potential energy final. This calculated, we have my mass, which is 76 kilograms, kg, multiplied by gravity, which is negative 9.8 meters per second squared, multiplied by the height of the funnel, which we calculate over there to be 1.52 meters. And then of course we have a negative out here because I'm working against gravity. And when we plug this into the calculator, we get 1133 joules. And the negatives cancel out, of course, so it's positive.
Okay, so now we want to find out like how much power Connor generated. So we know the formula that power equals the change in energy over the change in time. So this is just going to be our gravitational potential energy final minus gravitational potential energy initial, which is just what we calculated right here. So then power is going to equal 1133 joules divided by, we measured out, or we timed Connor as he ran up the stairs, and he did the stairs in 2.3 seconds. So 1133 divided by 2.3 equals 492.6 watts.
And then if we use that, 492.6 watts, divide that by the 1200 watts per hour that my hairdryer needs, we get, the watts cancel out, 492.6 divided by 1200 equals 0.41 hours. Converting that to minutes, we multiply it by 60, and we get 24.63 minutes. So he can't power it for an hour, but he can power it for 24.63 minutes.